So we will start about the collection. So yesterday I taught you about the list interface and what is the difference between the list interface and the set interface. Inside the list interface, list is an index-based data structure, but set is not an index-based data structure. Means inside the list, all the values means value which are added inside the list, that value will be add on the base of the index. Inside the set, the value is not add on the base of index. It will be add the values on the base of hash code values. Okay. Another thing is that inside the list, it will store only the duplicate element, but inside the set, it will not allow the duplicate element. Yesterday we saw that if we add same numbers 2 or 3 times inside the list, it will be add that values 2 or 3 times. But if we add that values, if we add same value 2 to 3 times inside the set interface, that value will only add only once. Okay, that value only will add only once, and that will not add the values multiple times. That value will be add only once. For that, this can store any number of null values. Inside the list, we can able to add multiple null values. Inside the set, we can able to add only one null value. Okay, because null is a value, right? If you want to add null value here, means duplicate null value, if you want to add here, set will not allow, because set does not allow to store the duplicate element, and null is also one value. So if you want to store multiple null values inside the set, so it is not possible. After that, list follow the insertion order, means whatever order we have added the values, same order it will be store the values, in same order it will be print the value as well. But inside the set does not follow the insertion order. Suppose if we add 10 first, then 20 first, then 30, 40, so it will not store like that. It will be add sometimes 20 first, sometimes 30 first, it will be add, means it is not following the insertion order. But inside the list, it is following the insertion order. Means if we add 10 first, then 20, 30, 40, so it will be add the values, means, or it will be store the values like that only, 10, 20, 30, 40, like that. Okay, after that we can iterate the list element by iterator and list iterator. So inside the list we have two iterator as well as the list iterator. So what is the use of this iterator as well as the list iterator? With the help of iterator, we can iterate the value of our collection in the forward direction, and if you want to iterate the value of the collection object into the backward direction, inside the list we have a list iterator as well. It have one method, that is the has previous method. But inside the set, we have only the iterator. Means if you want to iterate the value inside the set, we can iterate the value is only into the forward direction, not into the backward direction, because the set does not have any list iterator. It only have the iterator here. Now we will take the example here. Suppose I want to create any example, any value from here, or any object of this list interface. So how we will create that? Because list is a interface and we cannot able to create the object of the list, because list is a interface and we cannot able to create an object of the interface, right? So what we will do, we will take one class, that is the array list, we will take linked list, vector, or stack, because this all the classes are implement the list interface. And if you want to make any definition of this as well, so we can make it definition as well. So if anybody will ask you what is array list, so what array list is doing? Array list is implementing the list interface, right? Array list is implementing the list interface. Means list is inherited by the array list, and we know as we know that interface into the class we are using the implements, right? Interface into the class we are using the implement. So we can say that array list is a implemented class of the list interface. We can say that array list is a implemented class of the list interface. Similarly, like that only, what is the definition of the linked list? Linked list is the implemented class of the list interface. If I want to make the hash set as well, we can make like that only. See, hash set is the implemented class of the set interface. Linked hash set is the implemented class of the set interface. We can say that. Or preset. Preset is the implemented class of the sorted set. Okay, we can make the definition like that only. Okay, now we will take any class from here. So suppose if I take the array list, so I will take here array list. Okay, simple, you have to create an object, because inside the array list we have a many methods are present. Whatever methods which are present inside the collection, or whatever methods which are present inside the list, that will come into the array list, because inside the inheritance we saw that if we inherit anything, whatever things present inside the parent class, that all the things will be present inside the child class. right? Whatever things which are present inside the parent class, all the things will come into the child class. So here is the list is the child class. Whatever things present inside the collection or the list, that all the things will be come into the array list. Okay. Now I have created the AR here. Inside the AR, what I am doing is simple. I will try to add the values. So first value I will add, that is the 10. Then I will add similar like that. Here dot add, and be able to add heterogeneous type of value. Heterogeneous type of value means different types of value. We can be able to add it here. So yes, we can able to add. First I have added integer, then I have added here the Java string value I have added. Now I am adding here the character, and after that same like that you can add, or you can add any number. You can add double value as well. You can add a float value as well here. I am adding here float value. System.out I am writing simple, and here I am printing the AL directly. And if I run this one now, all the things will be print here. See, 10, then Java is printing, then C is printing, then 1.2 is printing. Now we will see the properties of the array list. So what is the properties of array list? Array list are the index based data structure, and index based data structure means it will add the values on the base of index. Okay, it will add the values on the base of index. So what it will be do is simple, it will be create an array like that, array list like that. Okay. And it will be like that, it will be at the value like that. And here, okay, so here it will be add the index like that. See, 0, then here 1, then similar like that. Here is the 2, here is the 3, here is the 4. Now if we add the values here inside the array list, what it will be add? It will be add the values on the base of index. So if we add first value here, this value will be add on the first index. So we which where zeroth index. So where is the zeroth index here? So here is the zeroth index. Our first index is 0 index here. So it will be add the values on the zeroth index first. So 10 will be add on the zeroth index. After that, similarly like that, second value we have, that is the Java. Java will be add on the first index, because inside the array list it will add the values on the base of index. After that, C is there, so C also it will be added here. So I will copy this, I will paste it here. C will be added to the second position, and then 1.2 will be add on the again third position, third index. It will be add the values like that. If you add again value, it will be add on the fourth index. So this is called as the index base. If we add the values, if we add the value, it will add the values on the base of index. That is called as the index based data structure. Okay, it will be called as the index based data structure. So here array list is a index based data structure, means it will add the values on the base of index. If we add first value, it will add on the zeroth index. If we add second value, it will add on the first index. Then it will add, if we add third values, it will add on the second index. It will add the values on the base of index. That is called as the index based data structure. And whatever things we have inside that, most of the things are the index based data structure. Okay, after that, array list can store different types of data, that is heterogeneous type of data. Means inside the array list we can able to store different types of data. So first I have added here integer, then I have added here string type of value, then I have added the character type of value, and then I have added the float type of value. But here this is not the integer, this is not the string, this is not the character, and this is not the this is not the float here. If I remove this from here, and if I control space here, see what we are looking here, add, and here object e means this 10 Java C, and here whatever things we are adding here, that all are the objects here. That are, this is not the integer, this is not the string, this is not the character, these all are the objects here. And inside the array list, see, we can able to add the values on the base of index as well. See, if I want to add the values on the base of index, suppose I want to add any value on the zeroth index. Suppose I want to add here as the character value on the zeroth index, so and it will be add. If I run this one, so see, C is added on the zeroth index. After that, it will be added on the first, second, and then third. Means inside the array list, we can able to add the values on the base of index, because array list is a index based data structure. Inside the array list, we can store the duplicate value as well. If I copy this thing from here, and if I paste it here, we can able to paste it. And if I run this one, yes, it is allowing the duplicate value as well. Means if we add same value multiple times, it is storing as well and it is printing as well. So inside the list or array list, we can say that it is allow the duplicate values. Same like that, array list can store any number of null values. So null is a value, right? Null is a value only. So if I add here the null value, suppose if I remove this thing, if I add here null value, and if I run this one now, so can it will be add the null here? Yet yes, it is adding the null value here. Just if I copy this thing and if I paste it multiple times, so can we will paste it that if I run this one, see it is storing that and it is printing that as well. Means inside the array list we can able to store multiple null values as well. And array list also follows the insertion order. Insertion order means in whatever order we have added the values, in same order it will be stored and same order it will be print the value as well. See on the 0th index we are adding the C, so it is printing C. After that we have added 10 here, so it is printing 10. Then Java 3 times you added, so 3 times Java it will be added. The null we have added, so null we have added as well. See, suppose if I remove this one, otherwise you will be confused. Now if I run this one, so 10 will be added, so 10 will be then 3 times Java, then null, it is adding here. Means in whatever order we have added the values, in same order it will be stored and same order it will be print the value as well. Okay. After that, array list does not follow the sorting order. Sorting order means either in ascending or in the descending order. It is not following any ascending or the descending order. It is only following the insertion order inside the array list. Inside the whole list, okay, if you compare the list interface, inside the whole list interface, all the things which are present here, all the whatever properties this list interface have, that all the properties will apply for the array list as well, linked list as well, vector as well, and the stack as well. Okay, whatever properties the list interface have, all the properties will be applied for this all the things. Okay, now another thing is that what is the array list here? So suppose array list are the non-synchronized. So yesterday I told you, like if you have one resource and if you have multiple threads, all the threads will be execute that resource at the same time. That is only called as the non-synchronized. Before that also I told you, before that we learn about the synchronization, in that also I told about the synchronization. Okay, so this is the all about the array list. Anyone have any doubt till here? Anyone have any doubt? Okay, after that here linked list. So yesterday I told about the linked list, and yesterday I told you about how node structure will look like inside the, how node structure of the W linked list is look like. I told you yesterday only. So inside the linked list as well, linked list underlying data structure of the linked list is the W linked list or the circular linked list. I told you how linked list is look like. Inside the linked list as well, we saw the properties. Inside the linked list, we have a property same like a array list. See, what is the property of array list? Array list are the index data structure. So here also we have a property that is the linked list are the index data structure. Okay. After that, inside the linked list, we can store different types of data or heterogeneous type of data. So suppose if I create here linked list, okay, so linked list, okay. If I create here a linked list and same thing we will try it here, okay. And here I will create linked list. I have to change as well. Okay. Inside the linked list, can be able to add heterogeneous type of data, means multiple types of data can be able to add it here. So yes, first we have added here, so we can able to add it here. Then we have a string here. Then we have it null here. So can we able to add this here? If I run this one, same output we will get it here. Means inside the linked list we can able to add different types of data. Linked list can store duplicate values as well. Inside the linked list can be able to add duplicate values. So 3 times Java I have added, 3 times, 4 times null I have added. If I run this one, so it is allowing that it is storing as well and it will printing as well. Means inside the linked list as well, we can able to store duplicate values. After that, inside the linked list, we can able to store multiple number of null values. So yes, multiple number of null values also we can able to store inside the linked list. If I run this one, same thing we will get it here. Multiple null values we can able to store inside the linked list. Okay. After that, linked list follow the insertion order. In whatever order we have added the values, in same order it will be store the values, in same order it will be print the value as well. Okay. So first we added 10, so 10 is added, then 3 times Java or 4 times null it is adding on the console. Inside the not console, inside the linked list. Means linked list is also follow the insertion order, but a linked list is not follow the sorting order, as there is the not either ascending or descending, so it is not following that as well. Okay, inside the linked list as well, linked list only follow the insertion order. After that, linked list are the non-synchronized. Non-synchronized means if you have one resource, all the thread will be execute that resource at the same time. Okay, that is the all about our linked list as well. And yesterday I told about the linked list, like how linked list will look like. Inside that one node will be look like that. Here I will tell you once again. It have a loop node like that, and inside that we have three boxes. Okay, inside the first box it will store here the previous node address. Okay, previous node address it will be stored, and inside the next box it will added here next node address, and inside this middle box it will add here element, whatever element we have it will be add the element. And yesterday I told you how it is look like. Okay, after that, which is the next class here, that is the vector. So how vector will be look like? Vector and the stack both are the legacy classes before introduction of the collection framework, because collection framework is introduced into the 1.2 version. But before that, if they want to store multiple elements into the single object, what they did, so for that they have a vector stack hash table properties and dictionary. These classes and interfaces they have before the 1.2 version to deal with this like object. Okay, if they want to store multiple elements into the single object before 1.2 version, because inside the 1.2 version collection framework were introduced, so before 1.2 version they are dealing with the vector stack hash table properties and dictionary only. Okay, so inside the 1.2 version what they did, introduce collection framework, and whatever previous classes we have, or whatever old classes or interfaces we have, they re-engineer these classes, they added these classes or interfaces into our collection framework as well. Okay, legacy means old classes. What are the old classes we have? Vector and stack we have, we both have a old classes. Vector is also old class, stack is also old class. So before collection framework, vector and stack is already there, so we are using this vector and stack before 1.2 version. Okay, they re-engineer these classes and they have added into the collection framework. Okay, after that, if we talk about the vector here, so vector is a introduced into the JDK 1.0, and it is a implemented class of the list interface. Just I told you, like it is also implementing the list interface, and it is present inside the java.util package. You can say that. Okay. Now, what is the underlying data structure of the vector is? Vector is a growable or the resizable array. Underlying data structure of the vector is growable array or the resizable array. Now, if I want to create the vector, how we will create that? Simple, we need to create an object of the vector. So new, and here vector, new and the vector here. Okay. And with the help of the, we if you want to add the values, we can add the values or with the help of add method as well. Or if you want to add the values inside the vector, so you can use this method as well, that is the add element method as well. So if I want to use v dot add element method, so you can use that method as well. With the help of add element method as well, we can able to add the values here. So suppose I want to add here string value, so see we can able to add or not. So first I added 10, then I have added Java, then v dot add we will write. You can use add method as well, or you can use the add element method as well. Both are the same only. Okay. Another last one we will try to add with the help of add element method is here. And suppose I want to add here any float value, can we able to add it here? So 1.2. Okay. So 4 value we added here. System.out we will write it here. And same thing, whatever properties we saw there inside the array list and linked list as well, is a duplicate value, insertion order and all. Same thing also apply for the vector, because vector is also implementing the list interface. See here, so inside the vector, can we able to add heterogeneous type of values? So yes, multiple types of value we can able to add inside the vector. Another thing is that here, that is vector are index bit data structure or not? So yes, vector is also index based data structure, means if you add first value, it will add on the 0th index, then it will be add on the 1, 2, 3, right? It will add the values on the base of index. That is called as the index based data structure. Inside the vector, can we able to store duplicate values? So suppose I want to store this Java multiple times here. So can we able to store it here? If I run this one, yes, inside the vector as well, it is allowing the duplicate values. After that, vector can able to, inside the vector we can able to store the multiple null values. So I will add here one null values v dot add method you can use, or add element method also you can use. So suppose I will use here null. Okay, inside the vector only we have this method, that is the add element method. Okay, inside the vector and inside the stack also we have this method, because stack is also implementing the vector or extend the vector. If I run this one, so multiple null values we can able to store inside the vector as well. Okay. After that, vector does not follow the sorting order. Inside the vector, we cannot able to it is not following the sorting order. That is the either ascending or the descending. And after that, this is the another thing. This is the differentiate thing from the array list and the linked list. Array list and the linked list both are the non-synchronized, but vector are the synchronized collection. This is the only difference between the array list and the linked list. Inside the vector, we have a synchronized, but array list and linked list both are the non-synchronized data structure. Okay, so this is all about the vector. Inside the vector, we have many methods like first element. Suppose if you want to know which is the first element, system.out, you can write directly. Here you have to use b dot first element, so it will return your first element. So which is the first element here? It is 10. If I run this one, so 10 is printing on the console. After that, we have another method, last element. If you want to check the last element, the same thing you can write copy. If you want to know which is the last element inside the vector, so you can use here last element method. So it will return the last element of the queue, last element of the vector. So which is the last element here? 1.2. 1.2 is printing on the console. Another thing is that is the remove element. If you want to remove any element from the vector, so we can use the remove element method. B dot remove element. Sorry. Remove element. Okay. And here we have to write object. So any object you can write here. Suppose I want to remove the 10 from here. So can we able to remove that? We will write it here. And if I want to print it again, system.out, we will write here. Now if I run this one, so 10 is removed from the vector. See, 10 is not there now. First 10 is there. Now 10 is not there here. Okay. If you want to remove the values, you can use the remove element. On the base of index also, you can remove the value. So suppose I have right here index now. That is the suppose I want to remove the 0th index value. Now if I run this one, or you will be confused. Suppose I want to 0, 1, 2, 3, 4. On fourth index 0, 1, 2, 3, 4. On the fourth index we have C. So I want to remove this C from here. If I remove this one from here, add. Okay. So now if I remove this one, so can it will be removed? Yes. So C is removed from this one here. So you, on the base of index also, if you want to remove, you can use this method with the remove element add. Okay. After that last element, there is remove all elements. If you want to remove all the elements from the vectors, you can use the remove all elements method. We have another method inside the collection framework. See, I will show you. Suppose if you have this much element here, if you want to remove all the elements from the collection object. So here inside the vector we have a remove all elements method. Okay, and again if I print this thing from here, system.out, and v if I print it here. Now if I run this one, so it will remove all the elements from the vector. See, first we have this much element, and now we don't have any element here because it is removed the element. Now suppose if I remove this one from here, and now if I want to remove the element, you can use here the another method, that is the clear method. Clear method is present in collection interface. So now if I run this one, so it will also remove all the elements from the collection object. Okay, clear method is also used for the removing all the methods from the collection of. Another thing we have here is capacity. Capacity we can check, that means what is the capacity of our collection. So if I want to check the capacity, remove this thing here, v dot capacity you can check with the help of capacity method. If I remove run this one, so 10 is the capacity. 7, 8, 9. Here I think 1, 2, 3, 4, 5, 6, 7, 8. First the capacity of the vector is 10. Initially it is 10. If you want to increase that, you can increase the capacity as well. Okay. Now another thing is that here inside the vector, vector is also extends by the another thing, that is this tag. Vector is extends by the tag, means whatever properties inside the vector we have, that all the things will be come into this tag. And if you know, if you from the any computer background, you have some idea about this stack. Okay, so stack is a legacy class which are introduced in jdk 1.0, and it is also played inside the java.util package. And stack is extends by the vector, means whatever methods which are played inside the vector, that all the methods will be played inside this stack. Okay, and after that here inside this stack, stack class was designed on the base of last in first out. Last in first out, on the basis of this, in this, on the basis of this, our stack will be introduced. So what is mean by this? Okay, if you want to add any values into the stack, so how we can add the value? We can add the values on the means if you want to add any values inside the stack, so we can add the values with the help of this method, that is the push method. Either you can use add method or you can use the push method. Push method is also used to add any values into this stack. Okay, after that, suppose if I want to remove a new element, so how we will use that, how we can remove the elements from the stack? So we have a pop method. With the help of pop method, we can remove the element from the stack. So suppose if we come here and I want to create a stack, so how will create a stack? New stack I will write here. Okay, yes, I will write. Okay, now if I want to add any element into the stack, so you can use add method as well, or you can use here the push method. With the help of push method also you can use the add, you can add the value into the stack, or with the help of add method also you can add the values into the stack. Okay, now suppose I want to add here heterogeneous type of value. Suppose I'm adding here first java. Okay, another thing I want to add here is dot push. Suppose I want to add here the tail, that is the integer type of value. Yes dot push again, and after that suppose I want to add any character here, so can we able to add it here? Yes, we can able to add. Yes dot push again, suppose I want to add the float type of value here, so can we able to add it here? Yes, we can able to add it here. Means inside the stack as well we can able to add the heterogeneous type of values. Now system dot out we will write, and yes we will write. So now if I run this one, so all the values will be added here. And first we have added java 10c then 1.2. So java 10c 1.2 will be print on the console, means it is the add the values on the base of index, or it is following the insertion order, we can say that, right? It is following the insertion order, we can say that. Okay, after that here, if I want to remove any element from the stack, and how it will be add the values inside the stack, simple, I will copy this thing and we will come into the page. It is quite interesting. What is last in first out? Suppose I told you yesterday in short, like stack will be look like that. Okay, if I remove this thing from outside, now stack will be look like that. Okay, inside this stack how it will be add the values? So if I, okay, so inside this stack first we are adding java. So what it will do, java will be add like that, java will become here and java will be add on the bottom here. Okay, so first we are adding here java, so java will be add on the bottom. After that here, after that what we are adding here, after that what we are adding, there is next value, that is 10. So 10 will not add on the bottom, 10 will be add on the top of the java. Then c will be add on the top of the 10, then 1.2 will be add on the top of the sea, like water. If you fill the water inside the bucket, so it will be go into the downside first, right? Then upside, 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 like that it will become. Suppose inside the one basket, if I want to keep a books, suppose if we have one basket like that, suppose This is my basket, and inside the basket, suppose I want to keep any books. So how we will keep the book? First, we will keep the book like that here. Like this is our first book. Now, suppose I want to keep another book. We have to keep upside of this one, right? Like that, upside of this one we will keep. Suppose I want to keep another book on that, so we will keep another book like on that thing here. Suppose I want to keep another book, so on the top only we have to keep. Okay. Now I want to remove this yellow book. So how we will remove this book? First, I want to remove this green book. Then I want to remove the that is the blue book, then red book. At last we will remove. At last I will get this yellow book, right? And it will be add the values like that. Suppose I want to remove this Java from here. So what it will be do? First we have to remove this 1.2, then C we have to remove, then 10, and then Java we have to remove. Right? Suppose I use here the remove method. Suppose I use here the remove method. Yes dot pop. Pop is used for the removing the element from the stack. And again system dot out we will write it here, and S I will write it here. Suppose I use here pop. Pop means remove. So it will remove the topmost element here. So which is the topmost element inside our stack? Is the 1.2 is our topmost element. If I remove this from here, if I use here yes dot pop, so what it will do? It will remove the 1.2 from here. That is only called as the last in, first out. Okay, whatever element will become at the last, that will be removed. Suppose I added this green book at last. Suppose I want to remove all the books from here. So what I will do, I will not remove this book first. I will remove the this green book first, then I will remove this blue book, then I will remove this red book, and then I will remove this yellow book. That is only called as the last in, first out. Okay. If I use here the pop, pop is used to remove the element. Suppose again I use here the pop, yes dot pop. Again it will remove the topmost element. Now which is the topmost element? 1.2 is removed already. Now we have a topmost element, that is C. Now C will be removed from the our stack. Now this C will be removed from the stack. If I use here yes again, so C will be removed from the stack. Now here we have this is Java and the 10 here. Okay, so this is the stack. After that, inside the stack we have also multiple methods. That is the pop we knows to remove an element, push we knows to add an element. Pick E method is used for if you want to know which is the topmost element inside our stack. So for that we are using the pick. I will remove this from here. I will use here yes dot yes dot it will whatever topmost element we have, it will be print that topmost element here. See which is the topmost element we have inside the stack here. C, so it is printing C here. Now if you want to search any element, for that we have a search method. Inside that we have to add any object and it will be give that index. After that empty, if you want to know that our stack is empty or not, it will give you the boolean value. If our stack is empty, that time it will return true. If our stack is not empty, that time it will return false. And whatever properties we have, same property we have inside our stack as well. That is the it is following the list last in first out. It will follow the insertion order, and it is if we can able to add the we can able to add heterogeneous type of values inside the stack as well. Whatever properties the list interface have, that all the properties will come into this stack as well. Okay, so that is the all about our stack as well. Anyone have any doubt till here? Yes, bro. Okay. So see, so array list and linked list. So here we have two things, that is the array list and linked list. Array list will look like that, right? Array list will look like that, and inside the array list it will add the values on the base of index, right? So this is the array list we have, and how our linked list will look like? See, our linked list will look like that. It will create a node like that here. I will copy this thing. Okay. If I copy this thing here, I will paste it. Again, I will paste it. Okay. Our linked list will look like that. It is add the values on the base of double linked list, and inside this one, what is the difference between array list and linked list? So array list is based for the retrieval. Okay, array list is best for the retrieval, but if you want to add any values or if you want to remove any values, that time linked list is best. Why I am telling like that? Suppose if you have the array list, this is our array list. Here it will add the values on the based of index. So here I will add 0, then it will be add here 1, then here it will be add 2, then here it will be add 3, and here it will be add 4, then 5, and here it will be at 6 like that. Okay, and inside the linked list we have a mini memory. Here we have a node addresses 1002, and here we have a 1003. Okay, now suppose if we have a multiple elements here, suppose here we have 10, then here we have 20 like that, and here we have a 30, then like that 40. I will add the values here 50, 60, and here I will add 70. Okay, so here we have a multiple elements like 10, 20, 30, 40, 50, and 60. Now suppose I want to remove this 30 from here. I want to remove this 30 from here. So how I will remove this 30? I want to remove this 30. How I will remove this 30 from here? What happen inside the array is, if you want to remove any values, this all the values will be traverse here. 40 will be added on the second position, 50 will be added on the third position, the 60 will be added on the fourth position, then this 70 will be added on the fifth position like that. Now suppose we have a sixth element, so it will be done in very less time. But suppose sometimes we have 10,000 element, or sometimes we have 1 lakh element, so that all the 1 lakh element will be traversed, right? That all the 1 lakh element will be traversed. It will take lots of time. Okay, but if you want any values, suppose I want 60 value, so how we will get that? On the fifth value I will get this fifth index, and from this fifth index I will get the value directly. Means array list is best for the retrieval. If I want to get any values, that time array list is best. But if I want to add any values, or if I want to remove any values, that time array list is not best. Because why? It will be traverse. Okay, all the array list will be traverse. Suppose on the second index I want to add any values, so what it will be do? This 30 will be traverse to the third position, this 40 will be traverse to the this fourth position, this 450 will be traverse to the sixth position, and this 60 will be traverse to the sixth position. Okay, so array list is best for the retrieval, but it is not based for our add, for if you want to add any values or if you want to remove any values. Okay, but if we talk about this linked list, the linked list is not based for a retrieval, but if you want to add any value or if you want to do any manipulation, that time linked list is based for that. Suppose if I want to add any value, so what it will do? Here one arrow is there like that, right? I told you bidirectional arrow is there like that. So suppose if I want to add any value, so what it will do? Simple, we have to create a node like that here. It will create a node like that here, and what we need to do only simple, this arrow we need to manage. Here this arrow we have to point out to this, this arrow we need to point out to this. Okay, and here we need to add previous node address, and here we need to add the next node address, and here also we have to manage the next node address, because before that next node address is this. Now we have to manage this address, this node address here, and here we need to manage this node address. Means if we want to add any values or if you want to remove any value, that time our linked list is best. But if you want to retrieve any values, that time our array list is best. Okay, okay, bro. Okay. Now, anyone have any doubt inside any concept, array list, linked list, vector stack? Anyone have any doubt inside the array list, linked list, vector or stack? Okay, then we'll go to the set. What is set here? Set is easy only. So inside that we have three classes: hash set, linked hash set, and tree set. I will tell you one trick here, how to recognize or how to remember these things. Okay, I will tell you one trick here. So hash set, linked hash set, and tree set is also there. Okay, so what will happen here? Inside the hash set, it is not follow any insertion order. Remember this thing. Hash set will not follow the insertion order, but linked hash set will follow the insertion order. Hash set not follow the insertion order. Linked hash set will follow the insertion order, and inside the tree set, it is follow the sorting order. Okay, this is the difference between the three things here: hash set, linked hash set, and tree set. Okay, hash set will follow the insertion order. Hash set is not following any order, that is insertion order also it will not follow, and sorting order it will not follow. Linked hash set will follow the insertion order, and tree set is following the sorting order. Now, if I want to create that, how will you create that? Simple, will come here and I will create a new hash set. Yes. Okay, and another thing you have to remember, inside the set interface it will not allow any duplicate element. It will allow only the unique element. If you add any values that is in multiple lines, I will show you. Inside the hash set, see, inside the set interface means you have to remember that inside the set interface means it will not allow the duplicate values. It will allow only the means that is the unique value. It will not allow the duplicate element as well. Okay. So now hash set we will see. Inside the hash set, if I want to add the values, I will add here hash set dot add. So here also we can use the method, is the add method only. Okay. Now I will use here 10 first, 10. Then I will use here, I will try to add here edges dot add. Suppose I want to add here Java. So can we able to add it here Java? There is a string type of value. So yes. In edges dot add, I will try to add here the what type of values can we able to add. So yes, we can able to add edges dot add. I will try to add here one vector type of value as well. Now, suppose I want to print this one. So see what will happen here. Run this one. So see, first Java is added, then 1.2 is added, then C, and then 10. Means whatever type of order we have added the values, in same order it is not storing the values, and in same order it is not printing the value as well. Means it is not following the insertion order as well here, and it is not following the sorting order as well here inside the hash sheet. Okay, hash sheet it will not follow the insertion order, and it will not follow the sorting order as well. Now suppose I will add this Java multiple times, so can it will be allowed. So I will paste it multiple times here. Okay, and if I run this one, so can it will be allowed duplicate values. So I have added Java 3 times, but it is printing only the one time. Why? Because inside the set interface it is allow the only the unique values, it is not allow the duplicate values. Suppose if you add a one value 3 times or 4 times as well, so it will consider that value only once. It will not print that value 2 or 3 times. It will consider that value only once. That is the thing, that is the set interface does not store the duplicate element. Can we able to add here the null value inside the hash set? Hs.add. Okay, we have one class, inside that it will not allow the null value. So inside that and it will be allow the null values. If I run this one, yes, we can able to add the null values here. But can we able to add multiple null values inside the hash set? I will try to print it multiple null values. If I run this one, if I add multiple null values here, so it is considered as only one. Means inside the hash set, we can able to print only one null values. And can it will be follows the insertion order? No, it is not following the insertion order. Means in whatever order we added the values, in same order it is not printing the values as well. It is not following the insertion order as well. And if you want to iterate the values with the help of iterator, you can iterate the values. So how we will use the iterator? I told you yesterday, simple, we need to use the iterator method, and the iterator method will return one object, that is the object of the iterator. You can use that iterator. Okay, now another thing is that if I want the insertion order, so which class we have to use? Just I told you, inside the hash set it is not follow the insertion order. Inside the linked hash set it will follow the insertion order. So suppose if I want to create a linked hash sheet, I will create new linked hash sheet. Okay, I will create simple like that, and here linked hash sheet I will create. Okay, linked hash sheet I will create here. Now with the help of linked hash sheet, if I want to add any values, what happened? 1 minute. New linked hash sheet. Okay, LH. Right. Now with the help of this linked hash sheet, if I want to print that, 1 minute. If I want to print that, how will print that? So if I want to add any values inside linked hash set, so same thing, we have to add then 10 multiple times. I told you like lh dot add, then again if I want to print it anything, see I'm printing here this time. You can, if I want to add any values, you can use simple add method here. And if I want to add here even float values, can we able to add here float value as well? So yes, we can able to add the float value as well. lh dot add, can we able to add character value as well here? So we can able to add the character value as well. System dot out and lh value I will add, try to add here. Now if I run this one, first we added 10, then we added c, then we added 1.2, and then we added a. So inside that it is printing same like that, means it is storing and printing like that. Means linked hash state will follow the insertion order. But before that we saw the hash state. Inside the hash state it is not following the insertion order, but inside the linked hash state it is following the insertion order. Can we able to add duplicate values inside the linked hash state? So I will try to add multiple tens here. If I run this one, so only 10 is printing one times, means we cannot able to add multiple values or duplicate values, it will be not allowed. Then lh dot null add, and here I will try to add here the null value. Can we are able to add the null values here? If I run this one, yes, we can able to add here null value. But can we able to add multiple null values here? So if I print this one, if I run this one, okay, if I run this one, it is allowing only the one null value. Okay? It will allow only the one null values. If I want to add multiple null values here, so it is not allowing as well. Okay, it is only following the insertion order, but it is not following any sorting order, or it is not following any it is following the insertion order, it is not following any sorting order. Okay, this is the linked hash sheet. Inside the hash sheet it is not following the insertion order, but inside the linked hash sheet it is following the insertion order. Last thing is that, that is the tree set. Tree set is implemented by the sorted set. Now if I want to create a tree set, how will we create that? Simple, we need to create a new tree set. Okay, and remember one thing, inside a tree set, it will follow the insertion or it will follow the sorting order. So I will add here the homogeneous type of values only. And if you are adding here multiple types of value, that time it will give you the error. Okay, so here try to add the homogeneous type of values only. First I am adding here the 10. Then tree set dot add. Second time I want to add here 50, so I will add here 50. Yes dot add. Suppose I want to add here suppose 9 here only. Okay, can we able to edit here? Yes dot add, suppose I want to add here suppose 65, can we able to edit here? And system dot out we will write, and now I want to print the tree set. Now if I run this one, so first I had a 10, then 59 and 65. If I run this one, first we added it, added 9, then 10, then 50 and the 65. Okay, why? Because preset follow the sorting order, that is the either ascending or the descending. Suppose I want to print this into the descending order, how will print that? So it have one descending iterator, ts dot descending iterator, and it will print the values into the descending iterator. So I will write here descending iterator. Okay, with the help of the descending iterator, you can iterate the values into the descending iterator. Simple, we need to write here while loop iterator. If we have to use the two methods only, that is the hash next will return the true and the false value. System dot out we will write here. Inside that descending iterator dot next. Now if I print this one, 65 first, then 50, then 10, then 9. If you want to print the value into the descending format, you can use the descending iterator here. Okay, so now inside the tree set we can able to add the homogeneous type of values only here. That time only it is sorting that values, it will sort that values. After that, see here, can we able to add here multiple duplicate values, or duplicate values can we able to add here? So then I will try to add multiple times. If I run this one, so 10 will be add Three times? No. Right? Only one times it is added because inside this set it will not allow you duplicate values and it will allow only the unique values. So if you add here three times only, so it will consider as only once. Now, another thing is that can we able to add here the null value ts dot add and here if I add null value, can we able to add here null values inside the tree set? If I run this one, so it is giving the exception. Which exception it is giving? That is a null pointer exception. Means inside the tree set you cannot able to add the null value. If you add the null value inside the tree set, it will give the exception as a null pointer exception. That is the only thing you have to remember. We have three classes: hash set, linked hash set, and tree set. Hash set will not follow any order, not the sorting order, not the insertion order. Inside the linked hash set, it will follow the insertion order. Okay, inside the linked hash set, it will follow the insertion order. Inside the tree set, it will follow the sorting order as well as it will not allow the null value. Okay, that are the three things we have. There is the hash set, linked hash set, and the tree set. So anyone have any doubt till here? Anyone have any doubt till here? Does anyone have any doubt? Okay, so that is the thing for the today, guys. Today we saw what is list and what is the set, what all the classes which are present inside the list and all the classes which are present inside the set interface. We saw that. Tomorrow I will tell you what is the methods inside the collection and what is the map and how our iterator will be work. Okay. One other concept is also there, that is generics. Tomorrow I will tell that things. Okay. That is the thing for today, guys. If you have any issues, you can ping me. And today's assignment is that you have to create a program on the array list, linked list, vector stack, and hash state, linked hash state, and the tree set as well. Okay, you have to create that and you have to submit on the group. And if you have any issues, please ping me. Okay, and many people are not submitting the. Many people means only Murli is sending the assignment and nobody is sending the assignment nowadays. May I know the issues? Or Hari will be contact with you. And another thing is that from tomorrow, try to come at the 9:30 because at sharp 10 o'clock I will be starting class from the tomorrow. Okay, okay, guys.